chemistries to develop tethered bilayers. So what I'm going to tell you about is that the bilayers, what we like to develop is a bilayer system on a solid support that's sparsely tethered on gold as our coupling agent. So the idea would be to come up with a system where you can reconstitute, assuming again that the crystallization of these proteins may never be possible, particularly in the presence of the lipids. Can you come up with a sort of a robust way to generate a general platform for bilayer reconstruction? So as I said, his approach is the synthetic approach where he's focused on optimizing tethered lipid tethers to generate these floating bilayers. And then again, to create a platform such that you can then take these kind of self-assembled bilayers and port them into our particular structural measurements, whether they be neutrons or other electrochemical or surface plasma resonance, fluorescence, or what have you. So this is a picture, before I get into the details of the idea of the bilayer. So the idea is on a solid gold surface is to assemble a floating bilayer which would mimic a cell bilayer that's, again, self-assembled, in this case, with the lipids. And at the bottom is you have your tethered molecules. So what the tethers are, you'll see, is a series of basically lipids that are linked through ethylene oxide linkages to a sulfur atom that then can react with the gold surface. And then through a mixture of these tethered molecules together with beta methylphenol, these small molecules here, we create spacers. We can create fluidic spaces, aqueous spaces below the membrane, so that we have an aqueous layer here, a lipid bilayer here, and then an aqueous space on the bottom to allow proteins to stick through. So here are the close-up of the tethered lipid molecules that Dave's actually synthesized.